Vision Metering is proud to introduce our Vesta metering test board. It's designed to replace existing test boards manufactured by Weco, Avo, and RFL. The board is a brand new design out of the box. We used very little of the engineering technology from any of the previous test boards in order to develop this board. There's a lot of out-of-the-box thinking that went into this test board in order to reduce the amount of time it takes to test, to reduce the amount of time it takes to program a meter, and to reduce the amount of time it takes to reset a meter. So we looked at things a lot differently in terms of how we were going to build the thing. To begin with, we started with a new standard. We developed a three-phase 0 to 100 amp standard that's capable of a voltage range of 0 to 600 volts, and it's a true three-phase standard. So unlike other boards where they have three single-phase standards, we only have one three-phase standard, and the phase angles are all equally displaced at 120 degrees, so that the board functions just like the meter, or the meter functions just like it would in the field when it's being tested. Some of the things that are unique to this test board is that we used audio amplifiers for our voltage and current amplifiers instead of the typical voltage and current amplifiers that you can find off the shelf. The reason we did that was to minimize the amount of harmonic distortion on both the voltage and current, so when harmonics testing is performed, there's a lot less interference with the harmonics from the amplifiers themselves. The jaw system is very unique. It's a takeoff of an old RFL 5455 jaw system where the jaws are more like clothespins. And in the back we have a servo motor that actually pushes in the back to create pressure on the front. So we can adjust the amount of pressure that's necessary to hold the meter in place and adjust it accordingly. Another key unique feature is the Century 410 optical probe, which we designed specifically for this test board. And the Century 410 probe has the capability of a dual function. It can take pulses from the meter through the optical port for testing, and it can also program the meter or reset the meter with the manufacturer's software at the same time that the meter is being tested. So in other cases where you have a situation where you have to pull the arm out in front of the meter to collect the pulses and then move the arm out of the way to reset the meter, with this test board you can just do it all with one function. Another neat feature is the sensors that we have. We have two different sensors for the meters. We have an Itron Centron sensor, which picks up the pulses at the top of the meters, and another sensor which is used for the Census Icon meters, which has a pickup in the front of the meter that'll come down over the top of it and pick those pulses up. The board has an internal computer. It is a Intel NUC computer and is quite capable of handling all the needs of the test board, so there's no external computer associated with this. The board also comes with a scanner and a place to hang the scanner, which in other cases the scanner just hangs off to the side or lays off to the side, so there's a place for everything. Typically the only time you'll have to use the arm is if you're testing mechanical meters, and we have the capability of testing through hole, and we can also pick up off the disc edge. You can also use this for picking up pulses off of electronic meters. Standard connectors are used throughout the test board, such as RS-485 connectors to minimize problems with cables and what have you. The heart of the test board is the touchscreen. One of the biggest problems we have in our facility is where our testers will drop things on the keyboard and bust the mice, and so what we elected to do was go to a touchscreen for control of everything, so that we could keep everything out from underneath the bottom of the test board to keep our testers from destroying the keyboards and the mice. So everything is touchscreen. An example, every button has a function. On the options button, you can go through, you have exit, login, reset, settings, date, colors. You can select the colors for any of the buttons to make them look any way you want to. So it's up to you. There's the colors you want to select. One of the neat things that we have is a status, which shows how many meters were tested that day and how many meters have been tested cumulatively on the test board itself, so you can keep track of the productivity of your employees. To set up a meter is real simple. You have two different ways you can do it. You can either select everything manually. When you hit on the form number, it has form 1S all the way up to form 66S. You select whichever one you want, and it will come in, and in this case it's 240 volts, but we can make it anything we want, 120, 240, 277. We can select the current, and of course if you select the current at 30 amps, then when it does the light load test it'll do it at 3 amps, 10%. You can select the KH of the meter. We have all the common KHs set here. You can select the number of pulses for each one of the different tests that are going to be performed, whether it's series light, series full, series power factor, and then for the elements, the number of pulses that you want generated. Usually with a case of H of 1, we like to use 3 pulses, which gives us a good test. We also have the capability to select which port or which optics we want to use. We can use the Opticom port right here, or we can use a reflect, 1 hole, 2 holes, or IR, which we would use in the case of Itron Centrons and Sensus Flex nets. Also we have the Century 410, which again is this probe. Every manufacturer has a unique way of outputting their pulses. In the case of Itron, they output their test pulses through a light pipe in the top of the meter. In the case of Sensus, they have an LED in the front of the meter, and everyone else uses the LEDs in the optical port. Right now we're going to test a Centron meter, and it's very simple. We plug the meter into the socket, pull down the IR pickup, scan the meter, change to IR for this pickup instead of using the optical port, and then push the start button. One of the unique things about the Vesta test board is that the typical way of testing a meter is to compare the pulses from the standards to the meter. In the case of Vesta, it also uses the pulses from the standard to compare to the meter, but it also looks at the voltage and current to make sure that there are 2 good methods of making sure that the meter is accurate. So there's a comparison that occurs between the pulses and the voltage and current to make sure that everything is coordinated between each other to make sure that the test results are accurate. In the case of testing an Itron Centron meter, it'll take about 45 seconds. You can adjust that based on the timers. We typically test meters with a case of H of 1 with 3 pulses to make sure that we get enough energy to be accurate, especially in the light load test. And the test results seem to be a little more favorable when we use 3 pulses instead of just 1 pulse. You can, however, use 1 pulse, but the accuracy might vary a little bit based on 1 pulse versus 3 pulses. For a single phase meter, it's typically tested series full, series power factor, and series light, and then the results show up on the screen, and then from there you can save those results and move on to the next meter. It's very simple. When testing mechanical meters, it requires the use of an optical arm. as the mechanical meter has a disc either with one hole or two holes in it, and you have to set the test board up to accept either one hole or two hole testing. There's lasers in the top and the bottom, and there's a laser transmitter in the top and a laser receiver in the bottom, and you line the laser up with the visible light that is in the optical arm to the optical or to the disc. You also have the capability of picking up off the disc edge through this through the center optical transmitter, or you can also use this as a pickup to pick up pulses through the optical port or through the other light pipes or LEDs that manufacturers may use to transmit their test pulses. So in this case, we've already set everything up. We've got a Form 2S meter, 240 volts, 7.2 case of H, 30 test amps. We're going to use 3 revs as a test mode. We're using 2-hole, and we've already selected the 2-hole option for the optical pickup. So that's all set, so we'll start the test. One of the things you'll notice throughout the operation of the test board is that you don't hear a lot of clunking. You don't hear a clunk when you put the meter inside the jaws, because the jaws are operated by a servo motor and not a coil. You don't hear the opening and closing of relays that are associated with changing the current ranges from the standards. As an example, you'll hear a clunk on other manufacturers' test boards when you do full load, then you'll hear another clunk when it switches to light load, and you'll hear another clunk when it goes to power factor. You don't hear any of that in this test board because those relays don't exist. That's another point of failure that we don't have. The reason being is that the standard is capable of going from 0 to 100 amps and from 0 to 600 volts, and because it has that capability, there's no reason to make changes to the range. Now this one has come up in the red, 99.72. This is a mechanical meter, so typically the limit should be set at 0.5 instead of 0.8, or 0.2 rather, and that's why that's coming up in the red. Also, when you're testing the meter, you can notice that the pulse indicator is telling you it'll flash green when it picks up a pulse from either the mechanical meter or any of the electronic meters, so you have that. There's also an audible signal that comes out of the side of the test board, which we currently have turned off, which gives you an indication of a pulse when a pulse is generated audibly. The test board is very quiet. It was designed with super quiet fans. There's 4 fans in it. 3 fans are used to cool the voltage and current amplifiers, which are located in the back of the test board, and the fan at the top is used to keep air circulating across the printed circuit boards and other circuitry inside the test board. Everything has been thought of. Again, the test boards were designed to be efficient, fast, and to allow the increased throughput that we would typically have in our shop. We currently have 90 test boards throughout our facility. So far 20 of them have been replaced with Vestas. By the end of the first quarter of 2017, 70 of the test boards will be replaced with Vestas. So we're very confident. We've got a lot of time invested in these test boards. We've already run more than 30,000 meters across the test boards in our vision shop, and we're very happy with the results we get from it.